Today's video will be a review of parallel and perpendicular lines, how we find their equations and how they behave. So let's take a look at our next example here. We're going to find the equation of a line parallel to another line here. We're given a line y equals 2x plus 3, and this new line will pass through the point -5, 9. So the idea here is if we have parallel lines, if we have lines that are parallel, and we're given an equation already, how do we find the equation of a new line that passes through a point and is parallel to this given line? Well, the main thing to remember is that parallel lines, when you look at them graphically, they have equal slopes. So this first line we're given here, we have to think about what its slope is. Well, its slope is 2. So the current line has a slope of 2. That means that the line that is parallel to it will also have a slope of 2. We'll have two lines that both have slopes of 2. Once we understand the slope has to be 2, this turns into a problem just like we had last night. We have a slope of 2, we're passing through the point -5, 9, and now I just want to find the equation of the line. So we'll use the techniques from yesterday. So we'll start off with y equals mx plus b. I already know what m is, it's 2, so I have y equals 2x plus b. Now my job is to just figure out what b is. I'm going to plug in x and y here. 9 equals 2 times -5 plus b. Means 9 equals -10 plus b. I add 10 to both sides, and it's easy to see that b has to equal 19. So that means the equation of the line, which is parallel to the original one, is y equals 2x plus 19. So those two lines, y equals 2x plus 5 and y equals 2x plus 19, will be parallel to each other. So the main thing to remember is that parallel lines, same slope. How about an example that involves perpendiculars? Here's our second example. We're going to find the equation of a line perpendicular to a given line. This time it's in standard form, 3x plus 2y equals 5, and we want it to pass through the point 6, 1. So in this problem, I'm given an equation in standard form. Here it is, 3x plus 2y equals 5, and I want to find a line that is perpendicular to that line, and it has to go through that specific point. Well, here's the main thing to remember about perpendicular lines. Perpendicular lines have slopes that are opposite reciprocals. It means we have to do two things. We'll have to change the sign of the slope, and we'll also have to flip it upside down to make it a reciprocal. So that means for this line here, I have to find its slope. So let's consider this as line number 1. I want to find its slope. There's a couple ways you can find the slope, and I suggest the easiest way for you will be to rewrite it as y equals. So I'm going to start by taking the 3x and subtracting it to the other side. I have 2y equals -3x plus 5. And then divide both sides by 2. So I have y equals -3 halves x plus 5 halves. A lot of fractions, but not so bad here. But the main event here is to look at the -3 halves. The slope of this first line is -3 halves. So the original line has a slope of -3 halves. What will the slope of a line perpendicular to it be? Well, the slopes are opposite reciprocals. That means I'm going to take this slope, flip it upside down, and change the sign. So 2/3. So the new slope that we're looking for of the new line will be 2/3. So now once we know all that, we have all the information we need to find the equation of a line. We have a slope of 2/3. The line's going to pass through 6, 1. Do all of our same techniques. Y equals 2/3 x plus b. I need to figure out what b is going to be, so I'm going to plug in 6, 1. Y equals 2/3 times 6 plus b. 2/3 of 6 is 4. Subtract 4 to the other side, you see that b equals -3. So the equation of the line that we're looking for is y equals 2/3 x. Oops, let me make that prettier. 2/3 x minus 3. Okay. And what we like to do is verify this one. So we're actually going to verify this one. You can see here we have the two lines graphed. Here's the original line. 3 halves plus 2y equals 5. That's this blue line here. The new line is y equals 2/3 x plus 3. That's the purple line here. And you can verify that this new purple line does in fact pass through the point 6, 1, and they are perpendicular to each other. So with graphing technology, it's nice to be able to verify these things. So parallels and perpendicular lines, we're now able to do those successfully.